Welcome to IB Math Center. This is question number 5, part B of the MYP Topical E-Assessment Algebra series. For those of you who are here for the answers to this question, please note that the answers are 4ab to the power negative 2, 7ab, 3a to the power 4, b to the power 1, and 6a to the power 4, b to the power 2. For those of you who would like to look at the solution, feel free to pause the video here. And for those who are here for detailed explanation, let us begin. So the question says that the table below shows an example of a completed multiplication grid. In the last question, which was 5a, we looked at an addition grid. This is a multiplication grid. And what's happening here? 3 multiplied by 4 gives us 12. 3 multiplied by 5 gives us 15. And likewise, 10 multiplied by 4 gives us 40. And 10 multiplied by 5 should give us 50. Right. So we're going to carry on with the same multiplication grid, except that 4 of the elements are missing. But we know that the one here is a multiple of these two. Let's multiply them. So 7 over 2. A written here can also be written on the numerator. It is actually implied that it is part of the numerator multiplied by 2b. Now when there is no denominator, it is implied that the denominator is 1. Because these two fractions are multiplying, I repeat, because these two are multiplying, then we can cancel these two. If they were adding, subtracting, or dividing, we cannot cancel these two. Or another way to look at it is, we can first multiply all of it. So 7a multiplied by 2b would give us 7 2s are 14. A times b will give us ab. And then 2 multiplied by 1 is 2, and then 2 1s are, and 2 7 times 14. So what we're going to get is 7ab. So that's one of the 4. Now we have a twist here. Let's try and find out this number. Whatever this number here, or whatever variables are going to be here, those multiplied by 7 over 2a will give us 14a squared b to the power negative 2. Right? Let's look at this again. So 7a over 2 multiplied by this mixed tree box will give us 14a square b to the power negative 2. Right? This mystery box is here. Right. So if 7a over 2 is multiplying with this x, right? Let's, for simplicity, take this to be a variable. Or take it y, because we've got a multiply sign here. We don't want to confuse multiply with x, right? So let's just take this variable to be whatever this is going to be, y. So 7a over 2 multiplied by y is 14a squared b to the power negative 2. Then y, 7a over 2, which was multiplying, would go there and divide, right? Y alone is 14a squared b to the power negative 2 divided by 7a to the power 2. Right. Now we know that we can simply reciprocate this and change the sign to multiply and make it 2 over 7a. 14a square b to the power negative 2 stays as it is. And when there's no denominator, it is implied that the denominator is 1 and this is equal to y. Or the missing box, whatever those variables are. Right. Now let's multiply. Numerator with numerator, denominator with denominator. 14 times 2 is 28. And then a to the power 2, b to the power negative 2 divided by 1, 7a is just 7a, and then 7 4s are 28. We've got we've got a in the denominator, we've got a square in the numerator, so the a in the denominator will consume one of the power. We'll just be left with 1a, or a to the power 1, and then b to the power negative 2 will remain as it is. So this missing number is basically 4a b to the power negative 2. 4a b to the power negative 2. Right. Can we find this? No, we can't, because this is a multiple of these two. Right? We don't know this. We don't know this. We only know one of the term, and we can't find two terms if both of them are missing. So we've got to find out one of the two first. What we can do is, we know whatever the variables are going to be here, those multiplied with 4a b to the power negative 2 will give us 12 a to the power 5 b to the power negative 1. So we can use this data because we have two of the three terms. So one of the three terms is missing. We can use the two of the terms which are provided to find the missing one. So let's begin. So we've got this mystery box that we need to find out what terms are here, multiplied by 4a b to the power negative 2 is 12 a to the power 5 b to the power negative 1. So these terms are multiplying here. They'll go to the other side and divide. So the mystery box alone is 12 a to the power 5 b to the power negative 1 divided by 4 a b to the power negative 2. One could also write it down directly as like this, divided by 4a b to the power negative 2. So 3 times 12, a to the power 1, a to the power 5. We can subtract these powers. So take away 1 from 5, we are left with 4, and negative 1, negative 2. Let me actually do this in a step so that I don't leave you confused. So this missing terms are 3 a to the power 4 b to the power negative 1 subtracted negative 2. So negative into negative is positive, so we can write this as 3a to the power 4 b to the power negative 1 positive 2, and negative 1 positive 2 is positive 1. So this will become 3a to the power 4b to the power 1. Let's just pen that down here. 3a to the power 4 b to the power 1. Let's just check. Yes, 3a to the power 4 b to the power 1, 3a to the power 4 b to the power 1. We've got a tiny dot here. Let's erase that. Okay, now we can easily find the last term, and that is a multiple of 3a to the power 4 b to the power 1 with multiplied with 2b. So where do we do that? Shall we erase all of this? Yeah, let's just quickly erase all of this so that we've got some space here. Right. So 3a to the power 4 b to the power 1 times 4 times 2b this multiplied with 2b is the missing box, multiplied by 2b is the last missing box. So 3 multiplied by 2 is 6. A to the power 4, and there's no term in a here, so a to the power 4 will remain as a to the power 4, and b 1 multiplied by b to the power 1 is b to the power 2, because when you have a multiply sign, then the powers add up. So this is 1 plus 1. So that's the missing box. We can't further simplify this. So let's just bring that down here. 6a 4b 2. That's our last one. So I hope you liked the video. If you've got any questions, feel free to let us know either by commenting or sending us an email. Thank you.